Good morning. My name is Maria Lemke, and I'm the Director of Conservation Science for the Nature Conservancy here in Illinois. In preparation for restoration at Spunky Bottoms Preserve, our Emiquon science team has been in discussions with our partners and colleagues around how we might use the key ecological attributes, or KEAs, that have been instrumental for monitoring restoration at Emiquon and adapt these KEAs to assess restoration progress at Spunky Bottoms. The Spunky Bottoms Preserve is located about 40 river miles south of the Emiquon Preserve, situated just below the LaGrange Lock and Dam, and is designated by the green star in the lower left-hand corner of the river map shown on the screen. About 1,200 acres of the floodplain site is in Nature Conservancy ownership, and about 800 to 850 acres is in Illinois DNR ownership, of which about 600 of that is in the floodplain. So the red line represents the entire levee and drainage district that separates the site from the river, and the black and white photo then shows the site when it was still in agriculture, with the associated drainage ditches that kept the site dry for farming. The restoration began in the late 1990s, and the site recovered quickly into a high-quality backwater site, although there was no real water level control other than some very old agricultural pumps. Now, in 2013, there was an historic flood along the Illinois River that overtopped the levee at Spunky for several days at these locations on the site map indicated by white arrows shown on the left-hand side of the screen. Eventually, the levee breached along a side levee shown by the orange circle, and the site was completely inundated by river water. Now, because of the location of the breach, the river water could not drain out completely and was basically impounded at the site that left several adjacent public roadways underwater and totally impassable. So it was necessary to create a second notch along the river levee, shown here on the right side of the screen, to allow the site to drain completely. However, this intentional notching of the river level also created a completely unmanaged connection with the Illinois River. Now, this slide shows a timeline of the Spunky Bottom site. So early restoration conditions of the site are shown in the upper left, showing nice aquatic vegetation habitat, followed by the 2013 flood that resulted in the levee breach shown in the far right-hand corner, and the subsequent notching of the river levee in the lower left photo. So through time, there's been a lot of discussion about what these backwater wetlands should look like and whether they should just be returned to the river with unmanaged connections and allow river water, species, and nutrients to come and go with the river water levels. However, monitoring data from Spunky prior to and after this river levee cut show rapid degradation of the system after the creation of this unmanaged connection, including the loss of high-quality fisheries, vegetated habitat, and reductions in most of the migratory birds that previously utilized the site. So these data support the notion that an unmanaged river connection is not really a viable solution for a high-quality backwater habitat and species assemblages along the river. So in 2024, construction began at the site to repair the initial levee breach on the flanking levee and also to install a managed connection along the river levee where it was intentionally notched back in 2013. So this is a schematic of the water control structure. The Illinois River is on the right side of the structure, and Spunky Bottoms interior is on the left. The structure will be equipped with slots for sampling gears, including nets and other monitoring equipment on the Spunky side of the gate, where we can collect data on fish passage through the structure, transport of nutrients and zooplankton, and other data related to a managed connection to the river. To assess restoration at Spunky Bottoms as water management capacity is restored, we are building on the work of the Emiquon Science Advisory Council that was convened in the early 2000s with the goal of developing a framework to assess restoration at Emiquon as it was converted from farmland to floodplain habitat. Now, the council was comprised of scientists, land managers, taxonomic experts, conservation biologists, and many others. And this group convened a series of meetings over several years to discuss methods that could be applicable for restoring agricultural land back into high-quality floodplain habitat. Now, during the time frame of these meetings, a publication came out authored by Nature Conservancy scientists that detailed a framework for measuring effectiveness of conservation actions using methods that are scientifically sound, practical, and comparable among protected areas over time. This methods of success framework includes four core components. The first is to identify focal conservation targets. The second then is to identify the key ecological attributes for these targets. Thirdly, identifying acceptable ranges of variation for each KEA attribute as measured by certain specific indicators. And finally, rating target status based on whether or not the KEAs are within acceptable ranges of variation. So the Council assisted in identifying conservation targets that were indicative of a functional river floodplain system. And based on those conservation targets identified for the river system in the Illinois, and these targets were based on conservation targets that had already been identified in the Illinois River Site Conservation Plan that was published in the late 1990s. Key ecological attributes and indicator ranges were developed for Emiquon conservation targets based on the best available science, resulting in this document here, shown on the right, that was completed in 2006. So we are using these Emiquon conservation targets and the KEAs related to these targets as our basis for developing KEAs for Spunky Bottoms. Now, this slide just provides an example of what some of the KEAs for Emiquon look like and how we track the data. So in this example, the KEA is fish community assemblages and composition. Indicators are focused on native fishes with desired ranges for the number of native fish species, biomass, and catch rate for certain native predatory fishes. Now, much of the KEA data are collected by scientists from the Illinois River and Forbes biological stations, and we input these data annually into a spreadsheet like this. The inputs include relevant indicator information as well as citations to where the complete reports can be found. So this example shows data from 2008 versus 2020. The red coding indicates the data are not in range, and green indicates data are in an acceptable range. So in this case, our goal for native species numbers were not met in 2008. However, by 2020, we had reached that goal of 25 to 30 native species collected using standardized methods. So over the years, then we can track how rankings move from red to green or green to red, and just use this for management decisions for conservation targets. All right, so Parrish et al. Stated that in order for a single target to be considered conserved, all attributes for that target must fall within acceptable ranges of variation. So here is one example of how we have applied KEA data for riverine and backwater fishes at Emiquon. So data show that fish did very well at the beginning of the restoration, starting in 2008, where many of the indicators fell within acceptable ranges. However, it wasn't until 2013 when the Illinois River flowed over the levee at Emiquon that the number of indicators related to spawning and nursery habitat for riverine fishes reached acceptable ranges. So it was after this event that both young a year and adult riverine fish species were collected for the first time at Emiquon. Okay, so we have 66 KEA indicators currently exist for Emiquon. About 56 of these are being monitored. We have identified about 60 Emiquon KEA indicators that might be adapted for spunky. However, given the remoteness of the location and capacity, we're still in the process of developing monitoring methodologies that address KEAs, and that would be sustainable over the long term. So we are collaborating with researchers from the Illinois River and Forbes biological stations on what KEA data are already being collected at the site, as well as what additional data might be collected by modifying or adding additional monitoring research. Data from many of the fish KEAs could be collected by the Illinois River Biological Station, including indicators for native fishes and young embryo recruitment. Several bird KEAs can be collected by Forbes using their existing aerial inventory surveys, rapid assessments for moist soil seed production, and possibly using autonomous recording methods to determine the presence and absence of nesting birds. We might engage citizen scientists to conduct mussel surveys and or perhaps annual brood and nest surveys. The master naturalists are an interesting option. We've been teaching master naturalist classes at Emiquon for many years now, and this would be a good opportunity to engage them in floodplain science. Now, the Nature Conservancy will take the lead on a lot of the vegetation assessments. Sally McClure is testing out new methods to develop vegetation maps using aerial imagery and AI, and we will likely be conducting annual surveys for submerged aquatic vegetation. We're also looking into remote methods of collecting data on other KEA indicators that include bird use, hydrology, and water quality parameters. Additionally, we plan to conduct some sampling at the control gate to assess river connectivity in terms of transport, fish passage, and other parameters like water levels. So with the potential for frequent connection between the Illinois River and Spunky Bottoms Preserve, we have drafted 2 research objectives related to floodplain restoration and management. The first objective is to identify, monitor, and evaluate KEAs to assess restoration actions and address management questions related to balancing prioritization of different conservation targets. Secondly, we want to develop, implement, and evaluate site-specific strategies for reestablishing and maintaining healthy aquatic plant communities. These KEA monitoring efforts will be key to addressing these objectives, with the larger goal of integrating findings into the development of strategies with partners for improved management of the larger river system. The next few slides review some of the newer technologies that we are exploring for monitoring and evaluation at Spunky moving forward. One of these is using satellite and/or drone imagery with AI to produce vegetation maps that we can use to monitor vegetation changes over time. The vegetation map on the screen is one produced for Emiquon by Forbes Biological Station using aerial imagery from fixed-wing aircraft for 2020. And these maps go back to 2007. Now in 2023, we transitioned to using drone imagery rather than fixed imagery, primarily due to the increased cost of using the fixed-wing imagery. So going forward, we're exploring 2 options of using drone or satellite imagery combined with AI technology for vegetation mapping at both Emiquon and Spunky Bottoms. And Sally will be discussing this further in her presentation later today. Now, MODIS towers are used across the world as part of an international collaborative research network that uses automated radio telemetry to detect migration and habitat use of many bird, bat, and insect species that have been fixed with small radio transmitters. There are currently 3 MODIS towers at Emiquon that researchers from Forbes Biological Station have set up and maintained, and we have discussed installing a MODIS tower at Spunky to assess changes in bird use as restoration progresses. Now, last spring, a continuous water quality monitoring unit was installed at Emiquon as part of a collaboration between the National Great Rivers Research and Education Center, the Nature Conservancy, and the Illinois River Biological Station. This Grion buoy houses a multi-parameter sonde and weather station that is maintained by the Illinois River Biological Station. So the unit measures water quality parameters such as turbidity, dissolved oxygen, water temperature. It collects nitrate and chlorophyll A data, as well as meteorological data for wind speed and direction, precipitation, and humidity. And we are in discussions about employing a similar or smaller type of buoy at Spunky in the future. We've also had some preliminary discussions with Dr. Kara Andres, a new assistant professor in the School of Biological Sciences at Illinois State University. Much of KEA's research involves using molecular techniques, including application of environmental DNA to explore aquatic biodiversity. Now, a few ideas that we are exploring with KEA include eDNA methods, using eDNA methods to assess mussel diversity, presence and absence of certain fish species, native fish species diversity, and possibly changes in fish community composition over time. And Dr. Andres will be discussing her work further in a presentation later today as well. All right, another idea we're discussing is installing a wild sage node at Spunky Bottoms. There are currently 2 sage nodes at Emiquon that researchers from Northwestern and Argonne installed a few years ago. Now, these are equipped with weather sensors, cameras, and a microphone that gather environmental data that are accessible online. Now, we've discussed moving one of these sage nodes from Emiquon to Spunky Bottoms Preserve to support data collection that monitor changes as restoration proceeds there, possibly associated with hydrology, water quality, and bird detection KEAs. There is also the potential to deploy a McClure buoy-based platform at the site. This system was developed by Georgia Tech and tested over the last few years in northern Wisconsin and Minnesota, with projects associated with wild rice working with the Ojibwa partner organizations. Now, these could be used at our floodplain site to monitor water quality related KEAs in near real time and at a relatively low cost. So in summary, the KEA framework provides a rigorous basis for measuring success, but also for setting conservation objectives, assessing threats to biodiversity, identifying monitoring and research needs, and communicating management information to partners. We will continue to work with experts to develop KEAs for Spunky Bottoms Preserve and to monitor those KEAs related to vegetation, fish, mussels, and birds. We are also continuing to develop strategies for using newer technological methods for monitoring KEAs that include using AI, stage and MODIS towers, water quality and meteorological monitoring buoys, and environmental DNA methodologies. Thank you for listening, and I can answer some questions. Thank you.